Hello, game theorists. So you can solve 3x3 games just with pencil and paper. If you got a really complicated game though, you probably want a computer to help you. So let's talk about how could I get a computer to help me. So we have our setup that we had earlier. Attacker plays air with probability PA, land with probability PL. Defender plays air with probability RA, land with probability RL. So to set this up, I had to first write down the attacker's expected payoff. So my computer program here is Mathematica. I think it's available in the library computers. Unfortunately though, we just suspended in-person classes and stuff, so you guys probably can't go to the library. But in normal times, when you could go to the library, and when you do have big games, this would be what you do. So first I do a clear all just to start with for a blank slate and get rid of any stuff from any previous math problems you've done on the computer in the past. And now I write down the attacker's expected payoff. So we use pi for payoff. I'm using A for attacker, so pi A means attacker's payoff. So that was 0 times PA RA, but the 0 there, so that just cancels out, so I don't worry about that. We have 10 times PA RL, so I write out 10 times PA times RL. We have a 5 times PA times 1 minus RA minus RL, so I put that over here, 5 PA times 1 minus RA minus RL. I keep doing the same thing for all the other terms. So here I get 3 times PL times RA, so 3 PL times RA, etc. So I got to do a bit of typing just to get the attacker's expected payoff in there, but once I got that, the rest is really straightforward. So once you write down the expected payoffs, you gotta take partial derivatives and set them equal to 0. So to do that with a computer, we just use big D for partial derivatives. So this is saying partial derivative of attacker's payoff, pi A, with respect to PA. This one down here is derivative of attacker's payoff with respect to PL. So to run this code, I just click inside this block and then press Shift and Enter on my keyboard. And now I got my partial derivatives. So those partial derivatives have to be set equal to 0. So I use solve to do that. So I'm saying solve partial derivative equals 0, and the other partial derivative also equals 0. There are a couple of quirks here in Mathematica's language. Overall, I think Mathematica is really intuitive, but there are some weird things. So you gotta type 2 equal signs instead of just 1. Don't know why it is, but that's the way the program's set up. To solve more than one equation, you use 2 ampersands instead of just 1. Again, does not make a lot of sense to me, but just something to get used to. So we're saying both those partial derivatives equal to 0. And in brackets here, I'm telling it solve for RA and solve for RL. So tell me what those probabilities should be. So I go press Shift and Enter in that block to make that code run. And now I've got RA and RL. That was way easier than doing all that algebra. So now let's talk about the other part of the problem. We gotta find the defender's expected payoffs. So pi for payoff, D for defender. So pi D is defender's expected payoff. So I could get 0 with probability PA times RA, but 0 times that stuff is just 0, so that just cancels out. They could get minus 3 that gives a probability PL times RA. So you have minus 3 times PL times RA. So I type out minus 3 PL times RA. They could get minus 4. That was probably RA times 1 minus PA minus PL. So 4RA times 1 minus PA minus PL. And I also have minus 10 times PA times RL. I type that out over here, and so on. So you just do that for all these terms in the table. So with the computer, the biggest job for you is just typing out the expected payout, but that's not very hard. The computer is all the grunt work, which is all the algebra and the calculus, which takes some time, as you saw in the last video. So I got my expected payoff. Now I'm saying take the derivative of that with respect to RA. Then I'm saying take a derivative with respect to RL. So let's execute that code, Shift and Enter. So there are my partial derivatives. Very last step, set those derivatives equal to 0, and I'm going to tell the computer to solve for PA and solve for PL. So give me numbers for what those probabilities should be. So this derivative equals 0, and that derivative also equals 0. Solve for these guys. And that's how you get our answer. So you can be rest assured there are no mistakes in any of the answer keys because it's all going to be computer checked. I just run code very much like this to verify all the stuff in the homework, at least for the Chapter 7 material. So that's how you use the computer to solve the more complicated games. And that wraps up Chapter 7. Chapter 7 is probably the hardest chapter in the book just because of all the algebra that's involved in trying to solve these games. So after this, it's going to be downhill. So that's all we have for today. Take care and stay safe out there.